There's one other concept that we're going to use to understand the numerical implementations of our algorithm. These are now called Jupyter notebooks. They were invented a few years ago as IPython notebooks, and now they're called Jupyter notebooks. It's really a fantastic tool to make portable documents that are accessible through any web browser. And they are basically alive in the sense that you can combine static aspects of a document like text and graphs with dynamic aspects, meaning, for example, Python programming parts that can be run and change their output, for example, graphs. So I would again invite you to spend a little time in investigating the power of these Jupyter notebooks. And I will give you just a little example, if you have never heard this before, and how to operate with these notebooks. It's actually a very powerful concept to start projects, to develop projects, and to exchange information on particular projects with your colleagues that you're cooperating with. So this is what you see when you type Jupyter Notebook in your environment. A browser opens, and we're now in a directory where actually there is no notebook, so we will start a new notebook. So this is what you do here. So we start a new Python 3 notebook. At the top here you can give it a name, so let's call it my first notebook. Okay. Now what you see is, and this is characteristic of all notebooks, you see these small windows. So these windows can either be Python code, or they can be Markdown. So this is like a very simple word processing system where you can have text, you can have some basic formatting, and you can also include some images. Let's start with giving again this a title. So this is my first notebook, and now you need to run this. There are several ways. You can either use this button here, but you can also type Shift Return, and you can see now this text. You can add some basic formatting, for example, by adding a hash at the very beginning. This is like now you have a title kind of formatting. Shift Return, and you see this now in a much more bolder kind of font. Another way of structuring is now using two hashes, and we will start showing some Python code. So we say, let's look at imports. Again, this is now using Markdown, and we Shift Return, and we have a subsection. So what we do here is something very simple, which is show how to initialize a vector and plot a sine function, just so that you see how we can make use of these Jupyter notebooks. So in order to do that, we first import a NumPy, which is a library for dealing with numbers and processing. So as NP, so we import it as NP, which means we access these all these functions by np dot something. We also want to do some plotting, and for that we use the matplotlib library. So we import actually part of it. This is matplotlib dot pyplot as plt. So let's see what happens if we Shift Return. So we're now running it. You can see at the top this is now Python code. So if we do that, we don't get an error message. So that looks good. So now let's initialize a vector. Let's again add a subsection. Initialize vector. Shift Return. Wait, we have to change it to Markdown. And now let's use a function called linspace to initialize a vector. So np.linspace. We want a vector that's defined from 0 to 2 pi, 2 times np.pi, and we want to use 1000 numbers in that domain. Shift Return, and we now have a vector that's defined between 0 and 2 pi with 1000 numbers. Now let's do some plotting. Plot a signed function. So this is again a subsection, so let's give it 2 hashes, and also we give it the markdown format. Shift return, here we go. Now, to make it a little more interesting, let's define a wave number. Let's start with 1 and then plot a signed function. So we use plt.plot. We plot the x-axis will be x and the y-axis will be our signed function, so sine k times x. This is an element by element multiplication. Well, k is a scalar here. And also we need plt.show, open bracket, close bracket, and let's hope this works. We have an error here, and that's happening quite often, so we forgot the np dot. And that should do the trick. And yes, we have now a signed function in the plot. And the power of these Jupyter notebooks is actually now you can basically save this as an ASCII file, mail it to a friend if you want to start a project, and you can use this here to change the parameters. So, for example, let's just change k to 10. And what I recommend always is you basically then run all from the top, and you get now the graph, the signed functions with a different wave number. So that's basically about it. Of course, you can now start playing around with this. A very powerful, very nice tool that we're going to use later to illustrate the Python implementation of our numerical algorithms for the wave equation that we're going to develop. If you're interested in exploring some of the more advanced implementations of these Jupyter notebooks, there are a lot of examples for seismology, seismic wave propagation, data processing, spectral analysis on a platform called seismo-live.org. I invite you to maybe spend some time there if you're interested in learning more about how these Jupyter notebooks actually work.
I can see clearly now the rain has gone. I can see all obstacles in my way.